Okay, the neural networks are like our brain. So our brains, our brain have billions of neurons. Like I said, you have, each human being have close to 86 billion neurons, not million, billion neurons. And that's what I said, right? So I was just comparing with the animals also. Elephant has, almost 257 billion neurons compared to human. It has, almost triple times of, human brain's neurons. Okay, it has 257 billion neurons, and dolphin has 37 billion neurons, and even the fruit fly, it has 100,000 neurons in it. Okay, so right, so the neural networks are like, it's something like our human brain. Okay, so it's something like, neurons in our brain. Okay, these tiny cells, these are, something like a cells, right? These tiny cells that passes the signals from one neuron to other neuron. Okay, each neuron receives input and process it and decides whether to fire a signal to the next. Okay, so the neural networks in machines mimic this. Okay, just with math instead of biology. So we are human being. So in that case, right, our cells are fired, based on the biology. Okay, what is the question you have? Yes, see, Sadia Anmal. Yeah, what is the question you have? First of all, what is your background? Are you a data scientist or what? Or fresher? Yeah, go ahead. What doubt you have? Yeah, I will unmute it. Yeah, I already. Yeah. So you can unmute and talk now. What question you have? Sadia Anmol. Yes, go ahead. I have doubt is it's about AI or okay. Your doubt is that an AI or neural network? See, neural network falls under AI. Don't think AI is different. Neural network is different. Okay, it's all same. Artificial intelligence. Okay, is neural network is part of AI, artificial intelligence. The neural network also, right? So, what is artificial intelligence? What is the difference in human intelligence and artificial intelligence? Human, like we have intelligence. Each human have intelligence. What things we need to do, what we are not supposed to do. In case of any problem, how to deal with that and how to, solve that problem. Similarly, right? So the, we give intelligence to the systems like a car. The car can drive on its own. Okay, so in that case, right, in the case of car, we have used something called reinforcement learning algorithm, and it's also part of your AI. And also we have used convolutional neural network to do the image classification, segmentation, everything, right? So and they did so many things, many algorithms. They have trained it with the huge volume of data, and also based on the environment, the car can learn and what action it has to take, what course of action it has to take. In case someone crosses the road all of a sudden or out of the blue, I know how should I react? Okay, how do I prevent the car to go and hit or someone, right? So the car can take the decision on its own. So what we have done, scientists, what they did, they want to give the the intelligence to the brain or the brain to the systems. If you give the brain to the system, there is no manual intervention of human there, right? So the car can drive on its own. You don't have to have a driver there. All we have to do is, right, you can ask the passengers to get in the car and then tell the car, where it has to drop them. That's all. The passengers need not to know driving. Okay. So because we have already given the brain to the system. In this case, the system is car. Okay, so it's all falls under artificial intelligence. The neural network is one of the fundamental building blocks of your artificial intelligence. Okay, the neural network is inspired by human brain. It consists of layers of interconnected neurons that process your input data. So, like human biology, right? Even in our human brain, we have neurons. even the case of a neural network, we have, we use multiple neurons based on the number of inputs that you give it to the neural network. The unit creates by default that many number of neurons behind the scene. For example, you are giving age of a person and marital status and income and past or any pre-existing loans. So these information you pass, let's say you pass these four information to the neural network. So what neural network does is it will create the neurons, four neurons to receive these four inputs, and then it processes this information and it passes the processed information to your output layer. You have input layer, output layer. In between, we have something called hidden layer. In case of you want to extract the very complex pattern from the given data, so in that case of situation, we are going to have multiple hidden layers. So I just write it here. You just see it here. I just draw it here so that if I keep talking it, you will not be able to understand. So you have something like, this is your input neuron. For example, you have something called age. In your data set, you have a column called age, and you have marital status. This column contains single or married, and then you have something called gender, whether male or female, and then you have something called income. The customer income is about the bank data, okay, bank customers. Okay, you just assume that. You just assume that you pass these four values to the neural network. What happens is behind the scene, it creates the four neurons, something like this. Okay, this is called your input layer. Input layer. Okay, and then what it does is it passes this information to the subsequent layer called your hidden layer. Okay, and then you can see a lot of crisscross here. Every neuron in your input layer is connected to every other neuron in your hidden layer. And then see here, this is where the actual process is happening. Okay. And then finally, what happens? It passes this information to an output layer. Okay. Or let's you have something called output layer. So what we are trying to solve here is we are based on the data what we have it. We want this neural network model, which is a supervised machine learning model, to predict whether the given customer is eligible for loan or not. In the output layer, you can see 1 or 0, okay? And if the 1 is associated with higher probability, that means there is a higher probability that this customer is going to default. Or just think this way, okay? Instead of saying default, right? Let's say this customer is going to, whether I'm going to approve a loan to the existing customer, let's say I'm passing this information of one customer. So, according to this, let's say, it assigns higher probability, 1 here. So in that case, this customer is more likely a profitable customer. We can give the loan to him. We can think that way also. Okay, more profitable customer. That means, he can make the payment on time. Okay, good customer or bad customer. You think that instead of saying profitable, good customer. So one is a, let's assume that good customer, 0 is a bad customer. Okay. In that case, we are very particular about 1. So here what happens is along with the class label, either 1 or 0, it assigns the probability also. Okay, with that you can make out, for example, 1 is, what did I say, is a good customer. Let's assume that way. Okay, along with that, so this is called your class label. So basically, this neural network model has to either predict 0 or 1. Net, this model has to predict either 0 or 1. 0 means the customer is non-profitable. 1 means the customer is profitable. If those customers are profitable, I'm going to approve the loan. Okay, I have data set. What I do is, already the machine learning model is there, the neural network model. Someone trained the model. All I need to do just show the new customers, those customers, new customers, especially, right, those applied for the loan. I will show it to this neural network model. So it has to predict either 0 or 1. For example, Rajesh, his customer name is Rajesh. Rajesh, my model, when I showed the age and marital status and gender and income to this model, So what happens is, right, it has to predict either 0 or 1. It says, 1. That means along with that, it gives me probability. So what is the probability? Probability values lies anywhere between 0 and 1. So all of you must be knowing what is the probability. Instead of saying in terms of percentage, in the case of statistics, we say probability. For example, what is the probability of raining tomorrow? If somebody says, zero point 0.6 or zero point 0.7 or zero point 0.8, that means higher probability that event can happen. Okay, any value that is closer to 1 is nothing but that the event will likely to happen. The chance of happening that event is very high. Any value that is closer to 0, the chance of happening that event is very less. Okay, so let's say in the case of Rajesh, my model predicted the class label as 1, which means he's a good customer. But along with that, it gives me the probability. He's a good customer. What is the probability that you can say that this customer is going to be a good customer? If it says 0.82, there is a 0.82 probability that customer is a good customer, which means he is going to repay the loan. Okay, fine. So this 1 or 0 is called your class label or binary class. Binary means 2. The model has to predict either 1 or 0. This is called, the class label. Model has to assign. For Rajesh, let's say it assigned a class label as 1. That means, he's a profitable customer. Okay, profitable customer is fine. What is the problem that is a good, if somebody says, a person is good, how good a person is? The next question is, how good a person is? How do you know that person is, so good, right? So what you do, right? So here, in the case of machine learning model, this is called your class label. Not only tells a person is good or not, along with that, it assigns the probability also. For example, if you say 0.82, okay, this person is good customer, but my model says there is a 0.82 probability that this customer is going to repay the loan on time, or this person is very good. Okay, so that is what probability in class level you need to remember it. Okay, remember this. Okay, fine. Next, what we'll do is we'll move ahead and understand neural network algorithm. That is the next question. Okay, what is neural network? So what is your understanding? The neural network algorithm they created based on or it is inspired by the human brain. So they want to mimic the human brain, how it works, right? So they want the system to mimic the human brain. That's how the neural network algorithm came into picture. Okay, it consists of the layers of interconnect. Like I said, input layer and hidden layer and output layer. Why neural network? Why not other supervised machine learning algorithm? The neural network can handle the non-linearity in a better way, and also it can learn patterns. For example, you joined with Google, they give you 100,000 images to you. So let's assume that each image contains only one object, like either cat or dog. Your task is you need to, out of 100 million images, your task is you need to classify which all images are related to dog, which all images are related to cat. But these images contains the mix of both different breeds of cats and dogs. Manually, if you have to find out, it is impractical. But they want you to classify how many number of given images contains dogs and how many number of images contains cat. It's very difficult, isn't it, to find out manually. And again, they want you to classify it within a matter of few seconds. That is possible nowadays because nowadays the systems or most of the systems we are using GPU, not CPU. The GPUs are called graphical processing unit. It is 100 times faster than your CPU, your laptop CPU. Okay, it is 100 times faster than your GPU. Okay, neural network, now it can learn the complex patterns. To answer to this question, why neural network, why not other algorithm? Because the neural network, you can process the complex patterns. So you have input layer and output layer. In between, you can have as many hidden layers as you have it. These hidden layers are really, really helpful in terms of finding out the hidden patterns. So according to human, let's say if I show you some image that contains a bike or cat or rat or dog, you can, as soon as you see that, you can tell, hey, this is a cat, this is a rat. What is the big deal, man? So that's why the human brain is so, so, so powerful, but we don't use it effectively. Okay. But the thing is, if you want the system to predict whether or classify whether the given image contains cat or rat or right, so it needs it needs a lot of effort. It has to perform a lot of things behind the scene. According to us, when we as soon as we see the image, we can tell, hey, this is a cat, this is a rat, this is a dog. But in order for the systems, neural network algorithm, machine learning algorithms to understand each images, it looks at as a numbers, pixels. Okay, 0 to 255 pixels are there, right? So the when we show the image to the algorithm, neural network, so it converts that as a pixels behind the scene, and then with that pixels only it can classify, hey, this is cat, this is a rat, or something like that. So if in case of image classification also, right, so you can use a neural network because the neural network, it can learn complex patterns. We can incorporate more number of hidden layers between input and output layer. So that's how we can make your neural network to learn the complex patterns, unlike other machine learning algorithms. Okay, got it? Yes. What is the doubt? Yeah, no, our question is, Priya's question is, no, what is non-linearity? We will see that what is linearity and non-linearity. Little while, don't worry, Priya. I'll be explaining you what is the difference between these two. So it handles non-linearity and flexible. We will discuss this in a little later. Don't worry. It's flexible and end-to-end learning. Okay, it does this one. And then before we jump in here, I will just yeah, we will discuss about the linearity a little later. Okay, don't worry. Okay. Next, we will take a look at something called perceptron. Okay, now that you got a fair amount of idea, so what is a neural network? Neural network contains each layer contains neurons. The input layer contains neurons. Hidden layer also contains neurons. Output layers also contains neurons. Got it? Yeah. Yeah, that's what. Wait. Don't, rush. We will discuss it one after the other. So, one second, guys. I'm just, somebody is calling. Okay, next we will take a look at the perceptron. Okay, like I said, the input layer consists of neurons. Okay, neuron 1, neuron 2, neuron 3. X1 is a neuron, X2 is a neuron, and Xn is also a neuron. Okay, and here the perceptron, what exactly perceptron? It is the simplest type of neural network. Okay, in this case, so this is basically introduced by a gentleman called Frank Rosenblatt in 1958 also. I don't remember. Yeah, correct. 1958 year. Okay, so that time he came up with the simplest type of neural network. Okay, so it's the building block of all neural networks. Okay, so in this case of perceptron, the single layer perceptron consists of the inputs like x1, x2, and x3, and right, the inputs are content. Each inputs contain the weights. There is something called weights. Okay, W1, W2, W3, and apart from this, you have something called bias. Okay, and then you have activation function, and then the output. Okay, it will emit the output. Okay, the perceptron formula could be like this. Probably you can note it down. Your perceptron formula listen your output. This is your output, right? Output is equivalent to f of weight 1 x1 plus weight 2 x2, etc., plus weight n xn plus b. B stands for bias. This is nothing but bias. This is, the simplest form of your perceptron formula. Perceptron formula here, okay? So here the F is an activation function. We'll discuss this in detail about this activation function a little later, but you need to have patience, very interesting one, okay? So now, why perceptron is important, okay? So it is the foundation of the modern neural networks. And it's, a multi-layer perceptron. This is, simple perceptron, okay? So using that, you can solve only the truth table like AND or gate, you can solve only the truth table of AND or gate only. But exclusive OR, you cannot solve it using the simple perceptron like this, okay? So in practice or in reality, perceptron is not much helpful because in the real world scenario, we are using, we are working with very complex data. We need to solve very, very complex problems, okay? But for you to understand the stepping stone or the entry point, right? You should be knowing what is perceptron from the interview point of view also, okay? So the limitation of the perceptron is it solves only linearly separable problems. Priya, I will coming back. I'll be explaining you now, right? So this is the time that I have to explain what is linearity and non-linearity. Okay. So the limitation of the single layer perceptron, yes, it solves only linearly separable problem. It fails on problems like exclusive OR. Don't worry, I will explain it everything. You need to have patience. Okay. That's when we need multi-layer neural networks. Multi-layer neural. This is the one in real world scenario we'll be working on it most of the time. Okay, first of all, what do you mean by solving only the linearly separable problem? Okay, look at here. Where is that? Yeah. So this is okay. So let's say you have given two different classes. The circles are called dogs, and the cross marks are called your. Let's assume that cats. If I ask you, hey, can you draw a line where you can show, above that line, whatever the objects are, those are like dog, just below the line, whatever the objects you see are cat. So what do you do? It's pretty simple. What you do is you simply draw a straight line here, right? So if you draw a straight line here, this line is separating these two different classes. Classes means these are like, these are your cat, listen, these are like your dog. So in this case, right, since the data are like this, you can separate it linearly by linearness a straight line. You can separate these two classes using a straight line. Okay. This is called linearly separable problem. Using the perceptron, that is the foundation for neural network, isn't it? That's what I said. Hello. Sorry guys, some calls came from office. Okay, this is called your linearly separable problem. Okay, okay, you have some curiosity. Okay, in this case, how do I draw a line, sir? If I draw a line to separate these two different classes, cat and dog, it is not possible, isn't it? So can you draw a line here? If you draw a line here, what will happen? Or if you draw a line here, straight line here, what will happen? You have dogs along with that cats. This is, this is not called as a linearly separable problem. To answer to Priya's question, one second. So this is called linearly separable problem. This is non-linearly separable problem. So if it is, if I cannot use a straight line to separate these two classes, what can I do? You can draw something like this, right? This is a little bit complex thing. Okay, so in that kind of situation, the simple perceptron will not work. Will not work. So in that case, You remember, right? The perceptron contains only the input layer and then the activation function, the output layer. That's all. It did not contain the input layer, sorry, hidden layer. It did not contain hidden layer. To solve the non-linearly separable problem, you need to use multiple layer perceptron. So what do you mean by multiple layers? How many layers are there? You might be having that question now in your brain. So you have the simple thing, input layer, output layer, and then you have hidden layer. This is input layer and hidden layer, output layer. Each layer can contain more than one neurons, and every neuron in each layer is connected to every other neuron in another layer. That we will see it little later. At this moment, you please understand what is the difference between linearly separable problem and non-linearly separable problem. If a data set contains something like this, if you draw a straight line, you can easily separate the objects or the images that are related to dog, the image that are related to cat. Fine. But again, you don't have to do it. Okay. So with the perceptron, you can do classification, something like that. In the case of complex data, something like this, what will happen is, right, you cannot use perceptron. This is called non-linearly separable problem. In this case, right, still you can separate it, but it requires, the advanced version of your perceptron, which is nothing but multi-layer perceptron. Multi-layer perceptron, because this perceptron is single layer, right? Perceptron, multi-layer perceptron. It requires multi-layer. Which one? The non-linear separable requires multi-layer perceptron. Okay, fine. Now that you learned some terms, very good. Next, we will move ahead and understand. One second. We will understand some simple thing like the truth table. So, what is truth table? Yeah, before that, yeah, this is what we discussed, right? So, the limitation of single layer perceptron is you can solve only linearly separable problems, and it fails on problems like exclusive OR. Exclusive OR in the sense the non-linearly separable problem. If somebody says, how do you solve the exclusive OR problem, which is nothing but non-linearly separable problem, okay? So that's when we need multi-layer neural network. That's what I said. And in this case of the simple perceptron, you can solve AND OR gate. How many of you heard about AND gate and OR gate in the school time, or if you are a computer science student, you must be knowing what is an AND gate and OR gate. So in the case of AND, very simple. Let's say you have two inputs, right? Input one and input two. And if you use AND, 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0. So 1 and if the inputs are same, only then it returns 1 in the case of AND gate. Okay. In the case of OR gate, if the inputs are same, it gives us 1. Especially again, right? 1, 1, right? If the inputs are, if both the inputs are 1, then it gives you 1. Both the inputs are 0, it gives you 0. If any one of the inputs contain 1, it gives you 1. That is what your OR gate. Very simple, isn't it? Very simple. And the next one is the exclusive OR gate. So in this case, if any one of the values 1, only then it returns 1. Otherwise, it returns 0. Exclusive OR. Okay. AND gate and OR gate, you can solve it using simple perceptron, which means the linearly separable problem, you can solve it using your simple perceptron. If you want to solve the complex classification problem, right? So that is something like your exclusive OR gate. So in that kind of situation, you need to use multi-layer perceptron. Okay. Yeah, primary, yeah, single neuron, right? The primary unit of computation neuron is called your neuron. So they may ask you what is a neuron. A primary unit of computation neuron network is called a neuron. The neuron receives a vector of input features and multiplies each input. Okay, this is what we will see it little later. If I discuss too much of technical stuff, you will get bored. I will just start with the multi-layer perceptron. As we move further, as we move along, I'll explain you each and everything in detail. So what exactly multi-layer perceptron? So unlike our simple perceptron, the multi-layer perceptron contains input layer, hidden layer, and output layer. So let's you have two inputs, age and income. And along with you have something called bias. You remember this when it comes to neural network, right? So bias will be added automatically. Okay, we don't have to, add a bias manually. So everything is, done automatically. Okay, the bias will get added, here automatically. I'll explain you why bias is coming into picture here. Okay, you have age and you have income. The input layer contains two neurons, age and income. Here the circles represent what? Neurons. And then you can see the lines, connecting lines, right? In the hidden layer also we have two neurons corresponding to the input layer neurons. But here, in between the input layer and the hidden layer, there is a connecting line. These lines are called your synapses. Okay. So the circle represent neurons and the lines represent synapses. There is one input node for each attribute. Okay. And every neuron is connected to every other neuron. See, this one is connected to this one to connect to this one, and this one is connected to this one, and this one, and this one. Every neuron is connected to every other neuron. The synapses are connecting line between the input and the hidden layer. Okay, this is the one, the synapses. It's something like in a wire, okay, or bridge. This is the one connects the input with the hidden layer. Okay, and neurons within the same layer do not transfer in the information. This is very important, guys. Age will not transfer any information to income. Whereas in the case of hidden layer, the age is passed to your hidden layer. Income is also passed to your hidden layer's neuron. Okay. But within the same layer, the information will not get be passed. Similarly here. So this information will not be passed here. And the opposite is also true. And even in the case of output layer, this information will not be passed here. This will not. There is no kind of dependency here. Okay, or okay, these are the five things you need to remember. So what are the five things? The circles represent neurons and lines represent synapses. And there is one input node for each attribute. What do you mean by attribute? Attribute is nothing but the column age. For each column, you need to have it will create a separate neuron. Okay. So, and then every neuron is connected to every other neuron in the subsequent layer, and synapses are connecting line between input and the hidden layer. The neurons within the same layer do not transfer information with each other. Okay. Okay. Now the question is, yeah, very good question. Priya asked, how many number of neurons should be there in the input layer? It depends on the number of columns that you are going to use it. Number instead of saying columns in the machine learning world, we call that as a features. Age is a feature, income is a feature. Number of features based on the number of features that you want to pass it. That means number of neurons will get created in your input layer plus one. The bias will also get created. So the interview question is, how many number of neurons should be there in input layer? If they ask you, the number of neurons is equivalent to the number of training data feature plus one. Well, the one is nothing but your bias. Okay. The circle represents neurons, and lines represent synapses. If you want, you can take a note on this. Got it? Yeah, we will discuss about how this one works. The internal mechanism of this one is will work. Before we dive into this one, hey, okay, fine. What this line is going to do, so each line you can see W1, W2, W3, W4. So this is the W1, W2, W3, W4. These are called your weights, body weight, we say, right? That weight I'm talking. So W1, W2, W3, W4, W5, W6, something like that. W6. These weights are randomly assigned by the neural network. We don't have to assign these weights. Which weight I'm talking about? One second. I'm talking about W1, W2, W3, W4, and this is maybe right W5 and W. These weights are assigned randomly by your neural network algorithm. We don't have to assign it. Okay. So what happens is when you pass the age and income to this information will be passed to hidden layer. In the hidden layer, it performs some computation. The output of the computation will be passed to your subsequent layer called your output layer. Similarly, here what happens, right? Upon receiving this one, it performs some kind of computation and then it passes the information to this one. This is called activation function. What kind of computation it does? That term is called your activation functions. As soon as it receives the age and income, what these neurons does, right? The respective neurons, what it does is it performs some kind of computation that is called your activation function. And then, right, it emits the value to your subsequent output layer. For example, the given customer is profitable customer or non-profitable customers. In this case, it has to classify. For example, the customer, Rajesh, for this customer, for yes, age and income, I just pass to this. Okay, the hidden layer processes, information, and then it passes the output to the output layer, something like, profitable equal to 1 or 0. Okay, so it does the classification whether the customer is profitable or non-profitable customer. In addition to that, like I said, you can assign the probability also. Okay, something like that. Okay, so now the question is, what kind of computation is done in this hidden layer neurons? Okay. So for that, you need to understand something called neural network activation functions. There are two types of activation functions, linear activation function, non-linear activation function. As I told you, the linearly separable problem. Okay, so in that kind of situation, we will use linear activation function. Non-linear activation functions, like I said, the complex patterns, right? So in that kind of situation, we use nonlinear activation function. Now let us take a look at the different types of activation function that are available. The sigmoid activation function, tanh, ReLU, leaky ReLU, likewise, various number of activation functions are available. Don't worry, we will, we'll take a look at each and everything step by step. And then this is for your activation function in your hidden layer. Okay, the output layer also, right? It uses some activation. I just go back to the previous diagram. So here, right? So this is the one. These neurons are performing some computation. So it uses some activation functions to perform some computation. Similarly, in the case of output layer, it performs some kind of computation before, producing the predicted class label as 1 or 0. It performs some computation. Okay. So in the case of input layer, between the input and now the hidden layer, right? It can use any of this activation function. So what kind of activation function should I use it when? That we will discuss it little later. Okay. And in the case of output layer, the sigmoid function, in the case of binary classing, for example, whether the given customer is profitable or non-profitable, whether the given bank transaction is a fraudulent transaction, non-fraudulent transaction, that's a binary, isn't it? Either 1 or 0, either yes or no. So that is your binary classification. In that kind of situation, you can use sigmoid. For example, if you wanted to do the multi-class classification, not all the time binary classification. Can someone tell me what is multi-class classification? Give me an example, simple example. For example, you have the colors, right? So whether not the color, a patient, let's say a patient in the hospital case. Patient can have blood pressure. A patient can also have blood sugar. A patient can also have higher heart rate. Okay. So more than two classes are there here. So in that kind of situation, your algorithm has to produce, right? In that case, right, it has to assign the multiple class there. So for that kind of situation, multi-class classification, that kind of situation, softmax algorithm will be used. Sorry, this activation function, not algorithm, activation function. If it is a binary classification, you can use sigmoid. If it is a multi-class classification, you can use softmax. Okay. The same thing is applicable even the case of input layer, right? So between the input and hidden layer, you can use sigmoid function if you wanted to solve the binary classification problem. For example, if your manager asks you, he gives you the data and he wants you to uh, classify each and every customer, whether they are profitable customer or not. Okay. So profitable, instead of saying profitable, non-profitable, we say profitable is 1, non-profitable is 0. You just think that one or zero will be using it, only two values. It has, my model has to, please, my model has to predict one of these two values. Either it has to say one or zero. So that is called your binary classification. In the case of multi-class classification, out of the multiple class, for each instance, my model has to say, hey, yes, this is the one. Listen, this person is having blood pressure, or this person is having only the heart problem, or something like that. Okay, multiple class. Okay, multi-label classification. Right. So in that kind of situations, we can use sigmoid. Multi-label classification. We already explained you the same patient example. We'll take it here. In the case of same patient, right, you might be having multiple complications. So there are cases, some patients they can have multiple complications. In that case, for example, is Ashok. Ashok has high blood pressure, high sugar, and is a diabetic patient, and also he has a heart problem. Okay, so that that is called multi-label, multi-classes of the multi-classes. Right? Listen, you have four different types are there. Of the three little types, you just say, yeah, this patient is having only heart problem, or this patient is having higher blood pressure, or this patient has only this one, something like that. Okay, of all the of all the classes, it has to predict any one of the class. But here, for each instance, it has to assign more than one label. Okay, so for these kind of problems, if you want to solve it, you need to use these respective activation functions. And then linear, for example, you want to solve the regression problem. You want to predict the housing price, or you want to predict the stock price. The stock price, housing, these are numerical values. So in that kind of situation, you need to use linear activation function. You got some fair amount of idea about. So what these activation functions are all about at an high level. Still, you need to watch my video multiple times so that you will be able to understand very clearly. Okay. Next one is the ReLU, the rectified linear unit activation function. This is one of the very popular functions when it comes to deep learning and even in the case of neural networks. Okay, so what it does is even so this one, yeah, important, the relay is used in your hidden layers. Okay, so it is nothing but the weighted some values below zero. It will pass a value to zero. Okay, to the output signal. Okay, so in the case of non-linear activation, it's a non-linear activation function, guys. For example, you want to predict whether the given image is dog or cat. So in that kind of situation, you can use ReLU in your hidden layer. Okay, hidden layer, you can use this one. So what it does is whenever your function is less than zero, it gives you zero. And whenever it is greater than zero, the output remains same as input value it is. What did I say here? See, here you remember that previous picture, the multi-layer neural network. You have something called the input layer. This is your input layer, and you have the hidden layer, okay, neuron, and you have the output layer, right? So output layer. Or so your input layer, you remember the previous one, okay? So we have mentioned about two things here, right? And then here you have only two, so zero or one, right? So this one or zero, okay? This is input layer, your the hidden layer and output layer. So in this case, the hidden layer, it performs some kind of computation that we will see it with some working example. Don't worry. What computation or what formula it uses, that we will see it little later. Listen, it does some kind of computation. What are the output of your computation? Listen, the output of this computation is zero. It returns zero to this one. Okay. And for example, if the output is 250, it will send the output 250 as it is, as it is. Okay, or in case of the values are below zero or minus one, you are getting like this hidden layer first neuron perform some kind of the calculation. It returns minus one or something. Any value less than zero also will be considered zero. It will it will simply convert as a zero and send it. And any value greater than zero, it will it will emit that value as it is to this subsequent layer. You might be confused. So, okay, zero, any negative value also it will convert as a zero, fine. Why, any values above zero, it moves, it pass it as a 256 or as it is, right? Because in the case of, you remember, the images are viewed as pixels. The computers or the self-driving car, it can see the images in terms of numbers, guys. Please remember that when the self-driving car is driving on the way, if it finds the red light or green light or amber light, it cannot understand, oh, this is a red, this is a blue, or sorry, this is a red or amber, right? Based on the numbers only it can understand. Human can understand it is a red light. 'Cause how these systems can distinguish which one, what light is there in the traffic signal based on the pixels only it can understand. The pixels values are nothing but numbers 0 to 255. For example, you have something called 25, 15, 0, and 15, 25, 0. So this is the pixel number for a bike. You just think that way, okay? So this is not exact number, guys. For example, I'm telling you, okay? So your car is a self-driving car. So just before that car, one bike is going, okay? So how it can make out with a bike are based on the number, right? The pixel number of that image, okay? So this is an image according to that. So for the corresponding image, what is the pixel number? Oh, this is something like a two-wheeler is going on. I need to take a diversion or I need to slow down my vehicle. So that's how the cars are making a decision. Okay. So when it comes to the machine learning algorithms or deep learning algorithms, it can understand the images based on the numbers, which is nothing but the pixels. In this case, what happens? Your model is doing something here, the hidden layer. So, right, so it emits something like 225. They say 225. 225 means something like, it's a white color, okay, something like that, okay. This is a white color or something, or red color, just think that 225 means red color. Instead of, emitting, the 225 as something like 1, 0 or 1, what will happen? How the car can make out whether it's a red color or amber color or green color. Okay, so for that reason, the rectified linear unit is really helpful in the case of non-linearly separable problem. This is nothing but non-linear activation function. Really is used in your hidden layer, especially in the case of self-driving car, image classification, that kind of situation really is used in your hidden layer. This is one of the important interview questions. Don't forget it. Next one is the challenge with the relay is that negative values become zero. If any value is less than zero, it's a negative value. In that case, what happens is, it decreases the model's ability to train the data properly. Okay, any value below zero, simply you convert as zero. So in that case, it is not able to understand the pattern very clearly. Okay, to solve this problem, they came up with something called leaky ReLU. In the case of leaky ReLU, they introduced something called a small negative slope, so it does not have a zero slope. So in this case, this helps speeding up our training time. The range for leaky ReLU is minus infinity to plus infinity, whereas in the case of ReLU, 0 to plus infinity, but here minus infinity to plus infinity in the case of leaky ReLU. Okay, to address the issue with the ReLU, they came up with something leaky ReLU. And apart from that, they came up with something called parametric ReLU, PReLU. Okay, the PReLU function is given by, this is the one. Forget about this. This gives the neuron the ability to choose what slope is best in the negative region. Okay, it goes one step further, okay, than your leaky ReLU. Okay, that's where the parametric ReLU comes in. They can become a ReLU or a leaky ReLU with certain values of. Okay, so you said, okay, in the case of negative value, it gives us a slope. But what slope is best is also important, isn't it? So in that kind of situation, the parametric ReLU is really, really helpful. Okay, fine. Next one is the tan function. Tan function, in reality, not many of them use it. So this is one of the activation function of the node, right? So it's a nonlinear activation function. It contains the values between -1 to +1. So this is similar to your sigmoid. You try both, sigmoid and tanh to see which one's accuracy is better. End of the day, that matters, right? So, and next one is, right, in this case, right, hyperbolic tangent function is very much like your sigmoid function. And here, like I said, the values are, ranging between -1 to +1. Yes, Priya, you can try the tanh function also, activation function. Or you can try with the sigmoid function. Okay, sigmoid function is the proven one. Better you can use the sigmoid activation function. Next question is the interview question. What is the difference in parameter and hyperparameter in neural network? How many of you attended the previous session? The previous session we discussed in detail about the difference between parameter and hyperparameter. So what is the parameter? Parameters are the values for the parameters are estimated during the training of the model, machine learning model. So what is the hyperparameter? Before you train your model, before we train our model, we we choose some values, random values for the hyperparameter. So give me an example for hyperparameter, number of trees. For example, you have random forest decision tree. How many number of trees needs to be trained, or how many number of trains to be train trees must be used, number of trees, and the depth of the tree. So these are called your hyperparameter. You can tell before training of the model to the algorithm, hey, use 100 trees. And for each tree, the depth is only 3 or 4. Okay. That's how you can tell. But when it comes to parameter, you don't have any control. Here we have a control. As a data scientist, we have a control here, whereas here we don't have a control here. Because the machine learning model estimates the values for the parameter on its own. Okay, we don't have any control here. Okay, so these are nothing but the weights of your neural network, and the activation functions are something like your hyperparameter. Okay, some terms are confusing. Don't worry. When I cover this topic, how neural network works, you will be perfectly all right with majority of your doubt. Okay, so as you watch movie, the suspense movie, what will happen? So when you watch 50% of the movie, you'll get some idea, and 70% of the movie, when you watch it, you will get much better clarity. Similarly, right? When you understand this topic, your job is very simple to understand the entire thing. Okay, so this is your input layer and hidden layer and output layer. But this is, zero point zero 0.05 and zero point 0.1. So these two values, for example, this is the age of the person and this is the income. You might be asking, what is the, how come a age of person can be 0.05? How come a person's income is 0.10? Let's say you scale the value, data. Age and income, you scaled it. What do you mean by scaling? How many of you know the Z-score? We discussed about this, right? The Z-score is, what is Z-score, guys? My students, can you tell me? What is Z-score? Using Z-score, we can convert the values to a standard value, right? So the standard values are very, very smaller. So when you use the Z-score, this is the formula for the sake of newer people. You can probably do Googling, okay? Z is equivalent to X minus mu divided by sigma. Each and every, for example, this is the age, right? You need to, this my age, let's age is 26 and the population mean is, let's 24. 26 minus 24 is 2 and the standard deviation is population standard deviation, let's 1. So 2 here, Z value is 2 here. Okay, but actual value is 26, right? We convert the result to using Z score. That is how we got the age as 0.05 using Z score. So why do I need to do the scaling? This is called scaling. Why do I need to do the scaling? This is what we discussed in the past session. But those of you did not attend the past session, but still even for the existing students to help you to recollect. So why do we need to do scaling is, for example, age and income columns are there. Maximum, the age column can contains only the 3 digits of the maximum, right? 3 digits. Let's assume that a person can live, 100 years, 126 years, 150 years also. Let's assume that, okay? It can contain maximum, it cannot go beyond 3 digits, isn't it? But in the case of income or, the income, let's say you're a businessman, it can be zero or it can be 8 digits or 10 digits. Like in the case of Mukesh Ambani, maybe, 20 digits. It can be any number. The number of digits are more. So in that case, let's this is customer data, customer age and customer income. The income can contain any number of digits. But when you use both age and income in your machine learning model, what will happen is your machine learning model will get biased with the column that contains more number of digits. To overcome this, we do the scaling. So when you do the scaling, irrespective of the values, right, it will be something like, 2 or 3, 0.05, something like this, okay? In the same way, you just think after I did the scaling, the age is 0.05, income is 0.10. So now, what happens is this input neuron is connected to the hidden layers neuron, and then the same value is connected to the second neuron in your hidden layer. So every neuron in your previous layer, the input layer is connected to every other neuron in the subsequent layer. The same thing is applicable here also. The hidden layer neuron is connected to your output layer. And in here also, so in this case, yeah, so you have only one output, right? Yeah, it has to predict either one or zero, and bias also there. Look here, the bias, you need to remember it. In addition to, the input features, you have the bias. In addition to the output feature, you have the bias also here. Okay. So in this case, for the, these lines are called your synapses. This kind of a bridge or connecting lines, right? So the input layer communicates to your hidden layer via your synapses. This why are you just think that way, okay? So this is called weight one and weight two and weight. This line is weight three. It assigns randomly some value to these lines. Those values are called weights. Let's assume that in this case 0.15 is assigned to this this line, and 0.25 and 0.2, 0.34, right? Each the line got assigned with a weight, and these weights are assigned randomly by the algorithm. Let's assume that the value randomly assigned is 0.15, 0.25, 0.30, 0.2. Fine. As of now, you are clear. The hidden layer, I was talking about some computers and some computation. What it does is, right, it does some kind of summation. Okay. There are two computation done by hidden layer of each neuron. Okay, so in this case, the first computation, it does the summation. What it does is it takes each and every weights and then multiply its corresponding input value. For example, W1, look here, that's what we can see it here, right? So this is your W1. W1 input 1 is 0.05 plus this W2, okay, this line, okay, W2 into I2. I2, this is your income 2. I2, this is I1. Okay. So this is the one. So the weight 1 into input 1 and then weight 2 into input 2. So that is the formula it is using it first thing. And then we substituted these values. 0.15 is your weight 1 into I1 is your 0.05 plus weight 2 is your zero point 0.2 into 0.010 plus the bias is in this case in this case the bias is 0.35. Look here, even for the bias it assigns some weight. Okay, so 0.35 into 1 is this value. Okay, bias is by default in this case 1 here. Okay, if you solve this, you will get 0.3775. The first step, you got 0.3775, and then once it computes this value, summation, the next step is it is activating this one. Step 2, what it does is it applies the activation function. So in this case, it uses the sigmoid function. That's why I put S here. Okay, sigmoid function. The formula for sigmoid function 1 divided by 1 plus e to the power minus net h1. So here 1 divided by 1 plus this value you need to put it here. Okay, so e to the power e raised to the power minus 0.3775. If you solve this, whatever you value that you get right, that is the one will be passed to the subsequent layer. Okay. So as part of hidden layer, what it does is it takes the weights of each neurons and then it multiplies with the corresponding input value and then it subs that value. Okay. And then it applies the activation function. Clear? Fine. Next one is similarly, right? So W3 into I1 plus W4 into I2. Okay, in this case, similarly, right, you will get 0.59 or something. So this is for this one. See the brown color, these brown color lines are going to this one, right? So for that, we got this value. The same steps are applied. Two steps are there. First step is it takes the product of each synapses values with your corresponding input layer value. Okay, and whatever the value that you get it after you take the product of it, you need to take you need to apply the activation function. So here in this case we got 0.59, that is for this one. This value whatever you if you substitute this one, right, you will get some value that is for this one. So end of the day hidden layer will contain some value here, and then this one is your 0.59. Yeah, this one is already I computed here 0.593. Okay, this one is 0.59326. I just clear it for the sake of clarity. Okay, and here one second. I don't know why. Okay, so here for this input neuron, the value was, after applying this, right, 0.593 something like that. And for this one, we got 0.596, 0.596. Very simple. So this value will be passed your subsequent layer called your output layer neuron. So in this case, what happens? 0.01 is the weight for this one. Oh, sorry, 0.40 for the weight for this one into this value, 0.40 into this one, and then 0.50 into this value. Okay, so 0.5 and 0.0 plus the bias is the weight is 0.6 into 1, 0.055, right? So you need to take the activation, you need to apply the activation function, you get 0.75. So what is this 0.75 tells us? There is a 0.75 probability that customer is going to default. You just think this way, okay? Or the customer is not going to default, okay? So the customer is basically in our case, right? We wanted to understand the profitability, the given customer is profitable. There is a 0.5 percentage, a zero point 0.5 probability that customer is profitable customer, which means there is a 0.75 probability that customer is going to repay the money. Hence, approve the loan. Got it? So, how the output layer, how the neural network predicts the output layer value, right? So, this is how it performs the computations. This is a basic, simple thing. Hope you understood. So, what is multi-layer network? So, in the multi-layer network or perceptron contains input layer and hidden layer and output layer. Each layer contains neurons, and each neuron's layers is connected to every other neuron in the subsequent layer. In the case of hidden layer, what it does is it takes the product of the weights of the synapses to the corresponding input layer values. Okay, so and then it applies the activation function on it. Okay, the Z is your the output value, right? So after you take the product of these two things, and if you add these two value, whatever the value you get it, that is your Z. 1 divided by e to the power minus z, right? That is what your activation function, sigmoid activation function, whatever value that you get it. So in this case, 0.593 here. So in this case, 0.596, and then what it is, this value 0.596 into 0.50, you multiply it. And similarly, this value multiply this one, and then you take the activation function for both, and then and then you add all the things. Finally, you'll get this value. That is what your predicted probability. This is how it works. It is also called as a feed forward layer. Why? The each layer is fed by the previous layer, preceding layer. Okay, this is called a preceding layer. This is succeeding layer. Okay, for this, the preceding layer is input layer. For this, the preceding layer is hidden layer. Okay, for this, the succeeding layer is the output layer. Okay, the preceding and succeeding. Okay, so or simple term, right? For the hidden layer, the input is coming from the input layer. For the output layer, the input is coming from hidden layer. Hidden layer is first neuron. Okay, for this one, it also gets the output from the hidden layer second neuron also. Okay, so since the values are fed from the forward direction, it is called feed forward layer. Very simple, isn't it? This is how it works, guys. Now, let's say in this case, my model has given me, or this previous computation, we got 0.75, right? So what is the actual value? How do you find out the error? The actual is, let's say, 0.01, and you need to subtract that from your predicted value, that is your 0.278, that is the error. So what is the error here for those of your yeah, the weights are assigned randomly, which means based on the problem only, right? For different problem. Yeah, based on the given data set also. Based on the given data set, it arrives the weights automatically. Okay, it arrives the weights automatically. It assigns the weights automatically. Okay, so obviously, right? What do you mean by based on problem? Yes, obviously based on the different problem, based on the different data set, we can add additional clauses based on the problem, based on the different data set, right? So it assigns the weights accordingly. We don't have any control. You cannot change the weights based on your, arbitrarily, you cannot change it. Okay, it is calculated automatically. You don't have any control over these values. Okay, and this is called feed forward layer. And then let's you have computed the error now. Okay, you computed the error. So what do you mean by error, guys? Probably in your college they would have taught you if you're a data science student, right? So for example, the actual values, let's the predicted values, the actual value is one. Okay, and actually the customer is profitable, but the predicted value is 0.75. So if you subtract the predicted value from the actual, you get something like 0.278. This is the error. The whole idea of any machine learning algorithm or deep learning algorithm is try to reduce the error, as much as possible. Reduce the error as much as possible or as low as possible. Reduce the error as low as possible. As a data scientist, is one of the challenges that we pose it. It's one of the responsibilities that we need to try to reduce the error as low as possible. Okay, point two, is there any possibility that I can reduce it further? The lesser the error, better the accuracy. Simple example, for example, in the past, as per the historical data, or let's say, your model predicted 75 lakhs an house value. Your model predicted. This January, I bought a house. Before buying that house, I come to you and I ask Ajanta, hey Ajanta, what is the amount that I can get it if I sell it? So you predict and say 75 lakhs. Now I'm in the April month. Now I sold my house. I sold my house to 76 lakhs. How much he predicted Ajanta, he or she 75. But this is my actual, this is my predicted. This is A and B, actual and predicted. Actually, I sold it to 76 lakh, but he predicted 70. What is the difference here? Just 1 lakh only the difference. Very good. The accuracy is very good. Okay, so as the Ajanta's role is here, the data scientist, he or she, right? Her response, you need to try to improve the accuracy of this file. The accuracy is good, but still, if you make it 75.5, what will happen? Just zero point 0.5 lakhs only, or 75 lakhs. But just 0.25 thousand only difference. The error is very less. He predicted so accurately. Something like astrologer. When he says, right, so and so days in between, um, 20th of April to 25th April, there will be an accident. That's what he predicted. But on that day, what happened, right? Between 25 and 26, though you are so cautious, still there is an accident. Since you did some kind of remedy, somehow you escaped it. So in that case, what you will say? Hey, that guy's prediction is so accurate. Similarly, when it comes to machine learning model, higher the accuracy, the lesser the error, higher the accuracy. Okay. That means, right, the 25 to 26, 25 to 30, any day you will meet with an accident. That range he gave you, 25 to 30th. Correct range. Okay. Within that range, one day, the accident happened just because, you did some kind of remedy, all the things, somehow you escaped. But his prediction accuracy was correct. That means, the error is very less, very, very less. Instead of happening the accident between 25 to 30, if that happened, between 15th to 18th, what will you say? His prediction accuracy is wrong. That means error. Higher the error, lesser the prediction accuracy. Just remember this. Lesser the error, higher the accuracy. Okay. So our next step is we need to reduce this error as low as possible. What should I do? There is something called back propagation. There is something called back propagation. We need to go from the reverse. My model predicted 0.075. So what I need to do is I need to adjust these weights by taking partial derivatives with respect to each weight by using some kind of chain rule and all the other things, right? So what I know, I need to adjust, each and every preceding layer's weights to see is there any way by, adjusting the values of these weights, my prediction accuracy increases. For example, instead of zero point 0.7, 0.85 comes, right? Is so closer to 1. Good. The error is also less. It can maybe fall down to 0.1237. Lesser the error, higher the accuracy. We can say that way. Is there any possibility if I can reduce the error further? Yes, you can use back propagation technique using which you can reduce the error. How you can reduce it? Using back propagation, we can um, we can enable the neural network to adjust the weights. Okay. So iteratively, you need to keep change the weights. You need to keep change the weights. That's called iteratively. Okay. It's not, simply say, changing it 0.42 and 0.3. So it will change different, it uses different values at which set of or which combination of weights my model accuracy has gone up or the error went down. So how do I do that? There is something called gradient descent algorithm. Gradient descent algorithm. Okay, the back propagation uses something called gradient descent algorithm, using which you can adjust these values of each layer's weights iteratively until the error goes less. This one requires a lot of math. What we'll do is we'll continue on this upcoming Monday. That's a very interesting session. It involves little bit math. Don't worry. I will explain it to you in a very simple way. Don't miss out our upcoming Monday session. Tomorrow I have some other commitment. Hence, we will not be able to continue the session tomorrow, unfortunately. But instead, we will continue on this upcoming Monday night, same time. The meeting link, everything remain the same. Any questions so far? Likita, Srija, Ajanta, Arulanathan, and Dhruti C, and Shivayogi Math. You have any doubts, Priya, Ramya? How did you find this session? Did you guys find it very simple? I made it, as simple as possible. Fine, guys. By the way, we will share the recorded video. And why don't you share your WhatsApp number? Our organizer can help, sending our previous recorded session also. Yeah. Send us your WhatsApp number. our or else what you do best thing, right? I will just give his number 98406331 organizer number. If you say hi message to him and if you ask him to please share the previous recorded session, he'll be sharing it to you the playlist, and with that you can watch the previous session videos also. And the upcoming Monday after completion of back propagation, right? We will continue with the Gen AI part. That is very, very important. No matter what you are, and the enterprises now they are looking for associates with the Gen AI skill set. It became a mandatory skill set. If you say, I'm a data scientist, worked in computer vision, everything, fine, fine. Wait, we are in addition to that, we need a person who is very good at Gen AI. So for that reason, don't miss out our upcoming Wednesday. Maybe the link will change, and hence you need to follow up. Okay, follow up with our organizer 9840 about the link in case of any change in everything. Okay, this is for future reference. Also, you can use it. All right, guys. Thanks for all your patience. Hope you enjoyed this.